Okay, so we had seen already that it took a while for biodiversity, for life to get here, for biodiversity to evolve, easily 3.6 billion years for the 8.7 million species to be here where we are. We also saw how different human activities are causing the decline of these species, and some of these species are also going extinct. In the last section of the class, we started to look at what is humanity doing to prevent or stop the loss of these species, and we review the use of regulations that will minimize the extent to which overexploitation reduces populations, and we also review another strategy or approach to deal with biodiversity loss, which is this issue of protected areas, and we show how these protected areas still remain deficiency, and so were the policies as well. Today, we're going to be moving to another set of solutions to deal with the underlying drivers of biodiversity loss. This one's related to greenhouse gases. Let's just review very quickly. There are several human activities related to habitat loss, overexploitation, and climate change that are being driven by this increasing demand for household food and energy that comes from a higher number of people, and unfortunately different types of people from different places around the world have different effects. But that kind of reveals here the underlying pattern on how do we go from humans to these drivers. Again, as I point out to you, we review already the extent to which protected areas and regulations reduce overexploitation and habitat loss. Today, we're going to start reviewing some of the solutions to deal with this issue of climate change. When it comes down to solutions of greenhouse gases, it turns out that there is hundreds of solutions to minimize the emission of greenhouse gases. And here are some examples. Again, I just pull out a few solutions from divisuzuki.org. This one guy is very famous dealing with climate change, and he goes through his webpage and outlines some of the solutions that individual people like you or me can do. And there are other solutions implemented now at the country level as well. Generally speaking, though, when we talk about solutions to climate change, they can be grouped into two different groups: solutions that deal with mitigation and solutions that deal with adaptation. Mitigation relates to these solutions that try to fix climate change. Whatever is driving climate change, those solutions are part of mitigation. Adaptation relates to solutions that deal with the impacts of climate change. Basically, we are accepting that climate change is going to happen, so we better adapt to those stressors. In both cases, again, it's recognized that there is a negative impact of greenhouse gases on the planet. And again, the solutions here, when it relates to mitigation includes things like alternative sources of energy, offsets, different types of, for instance, restoration of ecosystems that will remove CO2 from the air, or maybe even carbon taxes or emission markets that will actually reduce the amount of CO2 that are produced. So again, here are just some examples of solutions that they relate to mitigation. In the adaptation side of things, we have solutions that basically accept that climate change is going to happen, and we better start figuring out ways that those impacts have less of an effect on humanity. If we are realizing, for instance, that sea level rise is coming or that floods are becoming stronger, well, we better start building houses that can withstand the hurricanes, maybe higher elevation houses so that they don't get flooded. If it's getting too hot, well, we need to figure out ways to cool down people so that people don't die during heat waves. And if you get wildfires, well, maybe we just have to have water nearby so that when these wildfires are there, they can be contained relatively quickly. So here again, you can see just examples that they relate to adaptation and mitigation. The IPCC, Intergovernmental Panel for Climate Change, that's an organization of thousands of scientists from around the world, and they come together and they put all of the evidence together as it relates to climate change. As part of this report that they write every 5 years or so, they have this table. In this table, they outline all of the different solutions as they come down to adaptation. And as you can see, there are adaptations for water, agriculture, infrastructure, human health, tourism, you name it, hundreds of solutions. And they also have a similar table for solutions as they relate to mitigation, right? Normally, you hear people saying that we gotta do both. We gotta do adaptation and we gotta do mitigation. I am not gonna get to a conclusion on that. I'm gonna let you make your own opinion on whether we should adapt or mitigate climate change. And I'm gonna use an analogy for me to give you hints into making your own mind about whether humanity right now, this generation, could mitigate or should adapt to climate change. In this analogy, I want you to think about Mike Tyson. And let's imagine that Mike Tyson is my friend. The two of us are pretty good buddies. But there is a problem on this relationship here, which is the fact that every now and then Mike Tyson just throws a swing at me. He fails to measure the extent of his force, and basically I get hurt every time that he just throws a punch at me, right? So that's a problem, right? So can you imagine being punched by Mike Tyson every time, despite the fact that we are very close friends, right? So this is a problem for me. Now, how can I fix with this problem? Okay, one solution will be for me to buy this protective gear. That basically is adaptation, right? Me accepting that Mike Tyson is gonna be punching me every now and then. I just protect myself, and I'm just gonna be walking all along wearing that protective gear, so that every time that he punches me, I don't feel the pain. The other alternative for me is to tell Mike Tyson, you know what, stop it, man. I want you to be my friend, but I need you to stop punching me, and that is mitigation. So I want you to make a distinction here, or of which of the two solutions will you choose? Will you choose to wear that protective gear for the rest of your life, or will you rather fix the problem from the beginning? Now, the same thing goes with climate change. If we adapt to climate change, a couple of things are happening there. The first one is that it reveals that we failed to fix climate change. We basically give up. In 50 years' time, that generation then is going to be, when they are being punched constantly by heat waves, hurricanes, wildfires, and all of these things, they're going to be regretting quite a lot that we decided to adapt rather than mitigating. Basically, this thing of us adapting is just like us accepting that we failed to fix climate change. Unfortunately for us, there is still time that we can reverse this thing. So that's the reason why I want you to really think heavily on this idea between adaptation or mitigation. Now, regardless of where we go for one or the other one, there are multiple solutions. And again, just like we did before, I like us to go through a couple of these solutions just to see how good those solutions are. In this specific lecture, I'm going to be focusing on this idea of tradable permits, which is part of the Kyoto Protocol. Let's just try to see what that is first. So the idea of tradable carbon credits is that you have the government, right? The government gives credits to companies. A credit normally is similar to 1 ton of CO2. Basically, the government comes and tells the company, here are some credits, and this is how much CO2 you can produce. The company, if it generates more CO2 than was allowed by the government, then this company has to go and either buy credits from another company or invest on ideas or solutions that will remove the carbon that they produce in the first place, right? So if you think about it, it's actually a pretty smart idea. In paper, it's pretty good, right? Again, you just give certain amount of carbon for every company to produce. If they produce more carbon than that, then they have to go and pay somebody else. The idea of this is that companies will be forced to optimize the use of electric energy that they have. Either they invest on technologies that makes the companies more efficient and less producing of CO2, or they put money towards other people that might be willing to make the effort to invest on these technologies to, again, reduce greenhouse gases. So in paper, it's a terrific idea. Let's see in practice. So the European Union is one of these few places around the world where this idea or strategy was put in place. And here you see the list of countries around the time 2005 to 2007 when this idea of the tradable carbon permits were put in place. And again, remember that the ultimate goal of these tradable carbon permits is to reduce greenhouse gases by either making companies more efficient or companies buying or paying other companies to reduce emissions. Now, when you go and look here, the amount of greenhouse gases produced by the different countries on these different years when the tradable carbon permits were in place, one of the observations that you can make here is the fact that in general, every year, countries produce on average more CO2 than the year before at a rate of about 1.2, almost 2% per year. So there was actually an increase on the emissions of greenhouse gases at the time when this strategy was in place, which was aimed to reduce greenhouse gases. So something didn't work there as planned. Several problems were identified when they were running this. The first one was the fact that governments gave too high of allowances to these companies on the CO2 that they could use. As a result, these companies were never in a need to trade, right? So let's imagine that a company produces 100 tons of CO2. That's the maximum that they can produce. The government went and gave them 200 tons. As a result, companies were never even closer to the CO2 that they were allowed to burn out. So they were actually having credits in excess. Now, the other problems, a couple of other problems that were identified with this issue of tradable carbon permits or credits is the fact that it was voluntary. As you guys know, the United States decided not to be part of this, and so were other different countries. And the problem of this idea to be voluntary is that it created this environment of unfair competition. While the companies or countries that were part of it were investing money into reducing carbon, money that they could rather be investing to make the companies more competitive, the countries that didn't participate were actually using the money to get an advantage. So again, that kind of doesn't really work out very well, this idea, if not all of the countries are in there. But unfortunately, right now, the way that it works is voluntary. And obviously, very few countries are choosing to go and spend money when it's giving them an advantage with other countries. Now, the third limitation that was discovered was the fact that this only works in developed countries, right? Developed countries are the only ones that have that kind of money to put into credits. Now, let's review another idea that was put forward to deal with this issue of reducing greenhouse gases and what is called the Green Climate Fund. This was part of the Paris Agreement. And what does this mean? So if you take a relationship between the degree of human development and greenhouse gases, electricity, or carbon footprint, again, the magnitude of an impact by the society as a function of the development of that society, what you find is this pretty neat correlation here. Basically, you think about it, a society, for you to develop increasing along this axis, basically, you need to produce a lot of CO2. Think about the fact that for you to have roads, you need to have roads so that you can travel. You need to have the internet, and you need to have electricity so that as a society, you can operate, generate revenue that will make the society more prosperous. But all of that requires certain degree of development that unfortunately requires a lot of CO2. So when you look at these countries here that are highly developed, obviously they are developed, but it has been expensive from the environmental side of things to get to that degree of development. Now, unfortunately, the problem with greenhouse gases is the fact that for these countries to become developed, they produce a lot of CO2, and that CO2 is having a burden, right? And unfortunately, that burden of greenhouse gases is being paid by the less developed countries in the world. So it's creating, again, this unfairness in who is profiting from destroying the planet and who is paying the consequences of this. So this is a reality, and a lot of the countries that are still in the process of development are not happy about this. Now, the other problem is that all of these countries that are developing, they want to develop as well. Well, what the hell, man? You guys are having the greatest of life there while we are here starving to death. So no, these countries eventually want to also develop. But what it means, though, is the fact that for them to develop, then they have to produce this massive amount of greenhouse gases here. So what this is creating is this idea of what is called the leapfrog, right? So the idea is to bypass the development of these developing countries through that stage in which these countries that were here produce a lot of greenhouse gases. But that requires money. And here is where this Green Climate Fund came in, that these developed countries are going to support the developing countries so that they can develop without passing through this stage of producing a lot of greenhouse gases. They commit to give $100 billion. And again, the idea of that is to bypass the stage in which for you to develop, you had to produce a lot of greenhouse gases. Basically, think about the incorporation of technologies, right? Having electrical cars, batteries, better infrastructure, rather than that producing a lot of greenhouse gases. The idea here is that you can transfer all of these technologies from the developed world to the developing world, but that requires money. And it was suggested that developed countries will pay $100 billion to support this. Unfortunately, when the reality starts happening, all of these countries, they realize that that's a lot of money, and in total, for several years in which this has been running, they have committed less than $10 billion already. So again, here is another idea that is pretty neat in theory, but in practice, it just don't deliver. So I don't really want to go through reviewing every single strategy. I just want us to focus now on whether there is a chance that we can succeed at fixing climate change. And for that, I want us to identify what are the bottlenecks that prevent these strategies of being successful. Again, by success, I mean to establish regulations that reduce the emission of greenhouse gases. Basically, how do we go from having human activities that produce greenhouse gases to regulations that make these things to have less of an effect? So what will be the process? I want us to think about this in a process way. Basically, the first thing that you will need is to have a good understanding that these human activities indeed lead to climate change. The second thing is that this climatic change is having an impact on biodiversity and people. Then once this scientific knowledge is gathered, you will expect that the general public will appreciate this, and by the general public appreciating then the politicians will implement solutions. So we can see here a process in which we can see how we can get to a ultimate solution that is successful at reducing greenhouse gases. So if we go through this pathway, let's see how well do we know the different components and where is it that there is a problem. Let's look at the first piece of the first part of this process, which is to understand whether climate change is happening or not. The evidence for this is pretty solid, right? As I explained earlier, almost any thermometer that has been put around the world over time has shown that the temperature of the planet is going hotter. The other thing about this increase in emission of greenhouse gases is that our understanding has become so good that we even know exactly that it's being caused by greenhouse gases, and we know exactly where those greenhouse gases come from. So that first part of the process of knowing whether climate change is happening and whether it's happening by human effects is pretty strong already. Here is another piece of evidence. Here in blue, you can see Earth system models developed by scientists from around the world showing the temperature of the planet if there were no greenhouse gases on the models. If you add greenhouse gases in those models, then you get the temperature that you see in red, and that black line here is the actual temperature of the planet. So you can see how the black line, which shows this increase in temperature, resembles very well these Earth system models whenever they are run with greenhouse gases, again providing extra support to the idea that this warming on the planet that we are seeing is the consequence of greenhouse gases. The second component, okay, well, the planet is getting hotter and all of these consequences are happening in their climate system, but does that mean anything for people? Well, yes. We already know that the consequences of these climatic changes are massive, from floods to droughts to heat waves, from corals dying, from polar bears dying. So it's not a very good looking picture, the consequences of these greenhouse gases and this increasing set of climatic changes that are happening. So again, if we go back and review these first two parts of the process, we can establish that we know these two parts relatively very well. Now, once the scientific knowledge is gathered and it becomes strong, then the next step in achieving a successful implementation of solutions is public acceptance. We need the general public to understand and accept the scientific knowledge that is created. Here I want to break this process into basically having scientific knowledge that increases public understanding, that then ensure that the public will accept this, that will eventually turn into policies. I want to now zoom in into this component of the process. Again, scientific knowledge transfer to public understanding that then it will lead to public acceptance. How does that happen? How do you transfer scientific knowledge to the general public? Well, generally speaking, it's done via the media, right? The internet, news channels, newspapers, and the media has been recognized as a huge impediment or problem to the conversion of scientific knowledge to public understanding. Interestingly enough, the reason for that is that journalists, people that work in the media, they normally like to give both sides of the story. So whenever they are writing a story about climate change and it's being caused by humans, they normally go and interview a scientist that believes that climate change is not caused by humans. As a result of them providing these opposite views on those newspapers that they publish, it creates an opinion among the general public that this is 50-50, right? And again, it's mostly the result of the journalists, when they write these articles, they give equal weight to the views of people that say that it's climate change caused by humans to scientists to the few scientists that believe that climate change is not happening. Here is the paper documenting this problem. There are actually two papers that I show here. Here in this column, you can see scientific papers showing that 100% of the scientific papers, basically of all of the papers that are published by a scientist in scientific journals, 100% of them consider that climate change is caused by human activity. 100%. Again, just documenting that the science is pretty solid, suggesting that climate change is caused by human activities. Now, if you were to take news articles, basically you go to the Washington Post, to the New York Times, the Guardian, all of these news articles, and take all of the stories regarding climate change and try to see what they conclude on those papers, what you find is that 52.7% of the papers suggest that it's a combination, the warming that we're seeing is a combination of human activities and natural fluctuations. And only 6% of those articles suggest that it's only the result of human activities. So I want you to see the huge contrast between a scientist, 100% of the scientists saying it's climate change by humans, but when you go to news articles, only 6% of them agree that it's humans, and actually 50-50 whether the climate change is caused by humans or natural fluctuations. So again, you can see the bottleneck starts here when we start transferring this information for the public, is the fact that journalists are failing to capture the fact that there is no controversy anymore. But this thing that they had to always show both sides of the coin is leading again now to create an uncertainty in people. The uncertainty is here, right? If, as you can see, anyone that goes and reads an article on the New York Times and the reporter just say, yeah, it's climate change caused by humans, but another scientist says that it's not. When a reader goes and read this, it creates uncertainty that reduces public understanding, that then reduces public acceptance. Now, the other problem on this transfer of knowledge are errors. And we already show in the section of climate change some of these errors. Some of these errors are honest, like for instance, the one that was documented in that lecture, pointing out how there was a spelling mistake on the 5,000 pages document. Again, it's just two spelling mistakes on a document that is 5,000 pages long regarding the extent to which the Himalayas will melt or not. And again, the problem of this error was that it was used by interest groups to suggest that scientists are alarmists, that now the consequence of that on the general public is that it fits into this issue of uncertainty. There are also errors that are false. Again, there are people just picking out these documents apart, and there are several documents that have several issues with that document that have captured international attention. Here is just one of them, in which they tried to find out another error that was found on the IPCC, and despite the fact that there were multiple reviews on this, it was discovered that there was not an error, it was simply just a statement that was not written well enough, but the consequence remains the same. Once you get the IPCC, something like the BBC News that is watched by millions of people from around the world saying that there was another error on the IPCC report, everybody that goes and read that now is thinking that these scientists are alarmists, and is again feeding into this issue of uncertainty. Another problem in the transfer of knowledge from science to the general public is the fact that scientists, we are very complicated people. The way that we communicate science among scientists is pretty hardcore. I want you to go and look into a journal, into any journal from the family of journals Nature. Again, those are one of the most prestigious journals in the world, and search into that journal for the word climate change. And you get all of these scientific papers, again, that have published something on climate change. And these are some of the articles that I found here. And I want you to look at the titles of some of these articles. Like, look at this one number 14. Again, we are talking about scientific article dealing with climate change. And the title of that paper is No Signature of Abyssal Carbon in Intermediate Waters of California, of Chile during deglaciation. Look at this other one, volcanic triggering of biochemical cascade during oceanic anoxia event 2. Well, I guess there was an event 1 as well here. The point that I'm making here is that I had a PhD, a professor, work on this thing for many, many years, and I cannot make sense on the titles of many of these papers. And again, just to highlight the scientific complexity in which we are studying climate change, and the consequence of that huge scientific complexity is the fact that there is a lack of interest from the news media. And as a result, a lot of knowledge is created, but it actually never gets transferred, right? So unfortunately, this detachment between the transfer, or this bottleneck in the transfer of scientific knowledge to the public, is creating a tragedy in my view. The first one is the fact that in the minds of people, climate change is actually would be something there, but now it's making people believe that climate change is not influencing them at all. It's like somebody else's problem. So the first tragedy of this detachment is that it's creating a sense of low relevance. So climate change, again, many people might be concerned about this, but it's not really relevant. Right now, there are other things that are more concerning. The other thing that is happening, again, is that there is an increasing skepticism as it relates to climate change. Here is just one of hundreds of papers that can look over time the extent to which people is believing in climate change or not. And here in blue, you can see whether people think that climate change is pretty bad, and you can see that the percentage of people thinking that climate change is pretty bad is decreasing, while the amount of people that think that climate change is being exaggerated, that percentage of people is actually going up. And again, just pointing out these trends on the degree of skepticism in the general public. The consequence of these two factors, again, low relevance and increasing skepticism, is that then there is a reduced interest to take actions. Why is the government interested in going and doing anything when on the eyes of the people there is low relevance and really maybe is doubtful the extent to which this is real or not? Now, and again, unfortunately, that lack of transferring knowledge from people, from a scientist to the general public, leads to politicians then to actually abuse this issue of climate change and just go with the wave. Politicians just go with the waves. Let me just show you an example that I find very interesting.
I don't speak for the scientific community, of course, but I believe the world is getting warmer. I can't prove that, but I believe, based on what I read, that the world is getting warmer. And number two, I believe that humans contribute to that.
My view is that we don't know what's causing climate change on this planet, and the idea of spending trillions and trillions of dollars to try and reduce CO2 emissions is not the right course for us.
And so I think it's important for us to reduce our emissions of pollutants and greenhouse gases that may well be significant contributors to the climate change and the global warming that you're seeing.
So I don't know if the sound was that great or not. Unfortunately, those were hidden cameras, but basically they capture the opinion of Mitt Romney, who actually I had a lot of respect given what happened recently, what has happened recently. But in these videos, it captured the opinion of Mitt Romney before the election when he was running for president, basically acknowledging that climate change is real and is caused by humans, to then, just at the moment of the election, actually saying that climate change is not real, or that there might be still a lot of ignorance regarding this. So this guy, in the lapse of a few months, just prior to the elections, changed his mind regarding climate change. I want you to think about why. Why will a guy like this will change his mind just a few months before the elections? Well, the first reason, I believe, is the fact that he realized that there is going to be no consequence for him to change his mind. Again, if in the eyes of the general public, they just don't care about climate change, or they just don't understand it, then there is no a penalty for these politicians to pay if they change their mind regarding climate change. But if they change their mind on the benefit of climate change, then you will think that maybe the reason why they are doing that is to get funding benefits for their campaigns. So again, I think that is revealed very well on that video there, showing the contrast between Mitt Romney early on saying that climate change is real and it's caused by humans and we have to deal with it, to then saying climate change is not real and we shouldn't invest on this thing. And that change of mind again reveals the fact that he realizes that there is no a political price to pay for that, and that there are actually benefits if they start kind of getting into the wagon with these oil companies that will probably give money to them. Now, going back though, just like we did before, whether these things are working or not, I want us to look at, as I point out to you, there are hundreds of solutions and several of them are being played as we work, as we speak, but are they working? So the best way for us to find out if anything regarding climate change is working or not is by looking at the profile of CO2 over time, which interestingly enough is being monitored in Mauna Loa here in Hawaii. That's the photograph right there. They had a sensor of CO2 that has been measuring CO2 since 1960, and here you can see the variability over time. What is interesting of this is that early on, back in the 60s, the amount of CO2 produced was only 0.82 parts per million per year, very little amount of CO2. The last year, the amount of CO2 produced was 2.4 parts per million. So as you can see, we have almost multiplied by 3 the degree of CO2 that was produced back in the day, despite the fact that on all of these years, we have worked super hard to reduce greenhouse gases. You can see that we have done no dent whatsoever at the rate at which we are producing greenhouse gases. If anything, actually, we have actually multiplied by 3 the rate at which we produce greenhouse gases. Now, what is intriguing also, again, just to see whether we are fixing climate change or not, is when we look at the profile of temperature over time. This is a figure from Professor Jansen that likes to put all of this data, update this data constantly. And what I want you to pay attention here is the trend in warming over the last few years, and check out the last 6 years there, showing how those last 6 years have been above average, right? So the last 6 years actually have been the top highest years since there is a record of temperature. Again, pointing out that not only the evidence suggests that we haven't stopped greenhouse gases, there is a very good record that the planet is actually getting hotter by the day. Again, if we are going to judge these solutions as they come down to deal with this issue of climate change, the best indicator is that CO2 keeps going up and the planet keeps getting hotter. So to summarize this lecture, again, dealing with the solutions as they relate to climate change, there is a huge array of solutions to climate change, many of them, but the reality is that all of them still remain limited by the incapacity of us as a species to transfer scientific knowledge to the general public. There is where the bottleneck is. Because again, if you get a society that is well educated, politicians will never play with this. Climate change will have been fixed years ago. And again, that's the reason why it's so important for us to figure out how do we break that bottleneck of transferring scientific knowledge to the general public. Let's leave the class there for today.